Hydrothermal vents are hot springs formed by underwater volcanoes. They're located at spreading ridges, convergent plate boundaries, spreading centers, and subduction zones of the Earth's tectonic plates. The process of forming hydrothermal vents begins with cold seawater seeping through the ocean's cracks known as fissures. After going through the fissures, the seawater continues to seep far below this point in the ocean crust. Energy radiating up from the molten rock deep beneath the ocean floor raises the water's temperature to around 350 to 400 degrees Celsius. As the water heats up, it reacts with the rocks in the ocean crust. These chemical reactions change the water in multiple ways. Including all oxygen is removed, it becomes acidic. It picks up dissolved metals such as iron, copper, and zinc, as well as it picks up hydrogen sulfide, hydrogen, carbon dioxide, and methane. The warmer water is now less dense and therefore more buoyant than colder water. So the hot hydrothermal fluids rise up through the ocean's crust. The fluids carry the dissolved metals and hydrogen sulfide with them. Finally, the hydrothermal fluids ice at the chimney and mix with the cold seawater. The metals carried up in the fluids combine with sulfur to form black minerals, called metal sulfides, and give the hydrothermal fluid the appearance of smoke. Many factors trigger this reaction, one being the cold temperature, and another is the presence of oxygen in the water. Without oxygen, the minerals would never form. Now leads to the formation of white and black smokers. Abiotic factors include the two types of hydrothermal vents, black and white. White smoker fluid is usually cooler, around 250 to 300 degrees Celsius, and flows more slowly than black smoker fluid. These chimneys generally are smaller as well. The white color comes from the minerals that form when the fluid exits the chimney and mixes with the seawater. The hydrothermal fluid from black smokers is so hot that it ranges from 300 to 400 degrees Celsius. The fluid carries dissolved metals from the deep beneath the ocean floor. When the fluid mixes with seawater, these metals combine with sulfur to form tiny black particles. These particles make the fluid look like smoke. Hydrothermal vents provide a harsh and toxic climate which only can support a limited amount of species and organisms. The soil condition at hydrothermal vent depths are igneous rocks or basalt, and minerals which are formed by the reaction of rock and seawater at such extreme temperatures. Abiotic limiting factors include extreme cold and extreme heat provided by the vent, as well as the pressure at the deep ocean floor, as well as lack of sunlight. Located in the abyssal-pelagic zone, major producers at hydrothermal vents are the bacteria living within the tube worms. The bacteria get energy by converting hydrogen sulfide to sulfur. They create food from the carbon dioxide, methane, or the other sources of carbon within the environment. Tube worm is essential to chemosynthesis because bacteria is packed within the cavity. The bacteria manufacture the sugars through chemosynthesis, and the tube worm absorbs some of the sugars and uses them as food. The secondary consumers include shrimp, crabs, mussels, and other small fish. The top predator is the octopus. There are several species of octopus that only live around hydrothermal vents. Some species have only been seen a few times. They live among and under clumps of mussels, and they eat crabs, clams, and mussels. Unlike the octopus, mussels and clams use filter feeding to get their nutrients. They rely solely off the nutrients given off from the hydrothermal vent. Common predator-prey relationships include octopus and clams, as well as octopus and mussels, and shrimp and tube worms. Adaptations to living in this environment include being able to withstand such extreme temperatures. As well as housing bacteria in order for the chemosynthesis process to happen. The giant tubeworm, as well as the Wassomiid bivalves, both have inhabitants of bacteria for the symbiotic relationship. And at the bottom of the ocean floor, it's inevitable that carcasses will fall from above. Deposit feeders have taken advantage of, such as the polychaete worm. Interesting adoption, in my opinion, is the vent shrimp Rimicus exculta, which, instead of having eyes, has a cluster of pigments that help sense radiation. So instead of seeing the visible light spectrum, they see infrared, such as bacteria. Due to lack of sunlight and therefore photosynthesis, plants do not survive in hydrothermal vent communities. Hydrothermal vents bring on many minerals such as gold, zinc, and silver, which leads to mining of the seafloor. Because of the fact that the hydrothermal vents hold more wanted minerals than any land deposits, the mining will put a serious threat to these hydrothermal vents. Hydrothermal vents have only been recently discovered. Scientists are still trying to find out what lies in these deep ocean communities. But in the process of their research, harm can be done. For example, an organism who has lived in the depths and who is not accustomed to light will not react lightly to the flashing lights of cameras. And the pressure change of being brought back up to the surface for examination will not result well in the organism's favor. Due to the recent discovery of hydrothermal vents, there have been no reported endangered species so far. Humans have not recorded the organisms there or have reported any progress, negatively or positively. One, though, can assume that endangered species are inevitable if the mining and human disturbance keeps going on.